This is section 2-2, conditional statements. We're going to start out with some definitions. It says that a conditional statement is a statement that can be written in the form if P, then Q. The hypothesis is the part P that follows the word if, and the conclusion is the part Q that follows the word then. Let's look at some examples that should make a little bit more sense. We'd like to identify the hypothesis and the conclusion of each conditional statement. I'm going to circle my hypotheses and we'll underline our conclusions just to make it a little bit easier for us. So our first example, it says, if a butterfly has a curved black line on its hind wing, then it is a viceroy. So our hypothesis, this is stuff that follows the if. So our hypothesis here is a butterfly has a curved black line on its hind wing. Our conclusion is the part that follows the then. So our conclusion would be, it is a viceroy. Okay. B is a little bit different. It says a number is an integer if it is a natural number. So it's not written in that if-then form, but recall the hypothesis always follows the word if. So in this case, our hypothesis would be, it is a natural number. Our conclusion then would be a number is an integer. Okay, we're going to skip C for now. I'd actually like y'all to try that on your own and we'll go over the answer in class tomorrow. Okay, so come to class with that answer. All right, many sentences without the words if and then can be written as conditional statements. To do so, first identify the sentence's hypothesis and conclusion by figuring out which part of the statement depends on the other. Okay, let's go over these examples. So it says, an obtuse triangle has exactly one obtuse angle. So our hypothesis here would be that a triangle is obtuse, and our conclusion then would be that it has exactly one obtuse angle. So our conditional statement would be, if a triangle is obtuse, then it has exactly one obtuse angle. Okay, B is a little bit different. B provides a Venn diagram for us. And if we look up at our definitions, for our Venn diagram, our hypothesis or our P is always going to be inside of our conclusion here. So if we have tarantula inside of spider, the fact that it's a tarantula would be our hypothesis, and the fact that it's a spider would be our conclusion. So we would say, if it's a tarantula, then it is a spider. Okay, a conditional statement has a truth value of either true or false. It's false only when the hypothesis is true and the conclusion is false. To show that a conditional statement is false, you need to find only one counterexample. Let's practice that. It says, determine if the conditional statement is true. If false, give a counterexample. If today is Sunday, then tomorrow is Monday. That's true, right? If today were Sunday, then tomorrow would have to be Monday. Sounds true. We don't have to do anything about it. B says, if an angle is obtuse, then it has a measure of 100 degrees. Remember, an obtuse angle is between 90 and 180 degrees. But it doesn't have to be exactly 100. So this would be false. And a counterexample could be maybe 150 degrees, right? 150 is obtuse, but 150 is not 100 degrees. Right? So 150 is obtuse. It does match our hypothesis, but it is not 100 degrees. It does not match our conclusion. Alrighty, we've got some more definitions here. So it says the negation of statement P is not P. And when we write that with symbols, we write that with our little squiggle symbol and then the letter P, not P. The negation of a true statement is false, and the negation of a false statement is true. Okay, so we had previously defined, we said a conditional statement is a statement that can be written in the form if P, then Q. Okay, using symbols, we would say P, arrow, Q. Okay, the converse of a conditional statement is when we flip the hypothesis and the conclusion. So instead of if P, then Q, we would have if Q, then P. Okay, the inverse is the statement formed by negating the hypothesis and the conclusion. So you'd say if not P, then not Q. The contrapositive flips the hypothesis and the conclusion and negates them both. So you would say, if not Q, then not P. Okay, it's a little bit confusing when we're just talking about symbols, so let's go through this example. It says, write the converse, inverse, and contrapositive of the conditional statement below and find the truth value of each. So it gives us our conditional. It says, if an animal is a cat, then it has 4 paws. Let's start by identifying our hypothesis and our conclusion. Remember, our hypothesis comes after the if. So our hypothesis in this case is that an animal is a cat. And our conclusion comes after the then. So our conclusion is that it has 4 paws. Then we want to determine what's the truth value here. Is this true or is this false? So if an animal is a cat, does it have to have 4 paws? For simplicity's sake, we're just going to assume that this is a normal, average, healthy cat, and we're going to say true. Okay, if it's a cat, it has 4 paws. Let's move on to our converse. Remember that our converse flips our hypothesis and our conclusion. So our converse would say, if it has 4 paws, then the animal is a cat. Okay, let's determine our truth value. Is this true or false? If it has 4 paws, then does it have to be a cat? I would say that this is false. If we're thinking of a counterexample, we need to think of something that does have 4 paws, but that is not a cat. I'm thinking of a dog. A dog has 4 paws, but is not a cat. Okay, let's look at our inverse now. Remember, our inverse keeps the same order of our hypothesis and conclusion, but we're going to take the negation of them. So we're going to say, if an animal is not a cat, then it does not have 4 paws. Okay, is this true or false? I would say that this is also false. I'm going to think of a counterexample where an animal is not a cat, but it does have 4 paws. I would think of a dog again. A dog is an animal, that's not a cat, but it does have 4 paws. So this inverse is false. Okay, and lastly, we've got our contrapositive. Our contrapositive flips our hypothesis and conclusion and takes the negation of it. So you would say, if it does not have 4 paws, then it is not a cat. All right, this one is true. If it does not have 4 paws, then it cannot be a cat. Okay, again, we're assuming that the cat is healthy. Okay, in the example above, the conditional statement and the contrapositive are both true. And the converse, that's an S, and inverse are both false. Okay, related conditional statements that have the same truth values are called logically equivalent statements. Okay, so the conditional and the contrapositive are logically equivalent, and the converse and the inverse are logically equivalent.